Good evening, welcome to my laboratory. What you're looking at there is the display screen of my Link DSO, and what I'm monitoring is the signal from this little Joule thief here. You can see it flashing, boom, boom, boom. Okay, that's a 2 series 12 parallel array. Or 12 parallel LEDs in series with another 12 parallel LEDs, and you can see it flashing. I have the, let me turn on the light here. I have the 1 microfarad capacitor 800K base connection made there, and I'm using an MPS A18 transistor because I don't have the BC337, and I have a 1-to-1 toroid on there. The inductance is a little low. I think it's about 380 millihenries or microhenries per winding, but this is what I'm getting. I am getting oscillation in bursts. Okay, so now let's look at the, and that's running on a battery that actually has a fairly good charge on it. This battery is indicating about 1.4 volts or so. But this circuit it behaves identically down to about 7 volt or 0.7 volts as far as I can tell. I've gone and unconnected the battery. There's my little battery holder. Okay. Anyhow, we'll just leave that running, and I'm looking at the collector of the transistor, or the LED anode, and what you can see there is that this is the baseline 0 indicator, and so we have at 2 volts per division here. We have the battery voltage of about 1.4 volts indicated, and that fuzz along there. And it looks like there's no oscillations happening, right? Except every once in a while you may see a burst going on. Okay, so what I'm going to do now is go to the trigger function up here, and well, let's see. First, let me raise the trigger level by taking the trigger line, that's that little red line there, and I'm going to raise it up to a value that I know should light the LEDs, something like that. Did you see that? Okay, so now that's our oscillation bursts coming in and showing up on the screen there. So in order to get that and capture it stably, let me take this trigger position and move it over to the left here, to there. Okay, and now we'll go up to the trigger control up here, and instead of using auto, we'll select single shot mode. Okay, and then when the scope triggers, it should just do one sweep and hold there, and that's what we see. Okay, so that's the single oscillation burst, and we're looking at that at 25 microseconds per division. Okay, so now if I go up to the scope go button and hit go again, we'll get another sample of that same signal. Okay, so now if I change the time base, let's see, let's go to 100 microseconds per division, and now let's get another sample by hitting the go button. Boom. Okay, so now you can see the oscillation starts here, the frequency changes, and it starts tapering off. So let's go up to let's go to 1 millisecond per division, and then hit the single sample button again. Okay, so there we have one complete burst, but we haven't hit the next burst yet. Okay, so let's change the time base again. So now we're at 5 milliseconds per division. Hit the go button. And that gives us one burst, but we still haven't hit the next burst. Since we're flashing at about twice a second or so, we need to go to let's see, at 100 milliseconds per division now. We hit the go button. And now we see 1, 2, 3 of the burst oscillations once we've triggered the scope. Okay, but you see how much blank space there is in between those oscillations, those bursts of oscillation. So I think maybe we might be seeing just this portion here, and we might be missing the bursts when we look at the Dark Alchemist's circuit. Okay, so let me go back to shorter time base. "25 microseconds per division." Hit the go button, and now here you can see again the first part of a single burst of the oscillation. And this is very interesting to me. The frequency increases during the oscillation. The amplitude goes down a little bit. Anyhow, that's a picture of a single oscillation, a single burst of that signal, and using the scope's single shot capability to capture the details. Thank you for watching.